Well, hi, good morning and welcome to my shop. So today I hope to finish off the alignment work on this radio and hear how it really works for real. But first, because I do these videos and I know some of my viewers are Canadian, you might be Canadian. If you are, then I'm addressing you here from Aurelia. Here's what I got in my mailbox yesterday. I'm guessing you got the same thing in yours. This just gives the straightforward instructions. I'm just going to point out something on here. All these important circles of things you're supposed to be doing, one of them is shown in red. This one. And what is that one? Try not to touch your eyes, nose, or mouth. This is the primary vector. We infect ourselves with our hands. This is the primary way we get infected. So this is the primary thing to stop. This is why wearing face masks is helpful. Not because it stops the virus. If it doesn't stop air, it doesn't stop the virus. It stops your hands from touching your face. So don't scoff when you see other people wearing face masks. And I'm busily looking for ours here. Somewhere I had some of those, just those simple cloth face masks, just to keep our hands away from our mouths. And that's only when we go out shopping. We've realized we don't have 8 weeks worth of food here. No way. So we're planning an excursion, probably tomorrow, but maybe today. We're doing all the things we can. We're trying to order stuff, have it staged for us, all that kind of stuff to try to limit contact with people. And I heard that in Canada, 90% of the population is totally on board with this thing. I can't imagine it could be any higher than 90%. Totally on board with this. My guess is in a couple of weeks, the other 10% will be on board too. Or they'll be on board or they'll be in the hospital. So my last thing I'd like to say to my fellow Canadian, please take the time to watch a video on the 1918 flu pandemic. You need to understand what this is going to look like going forward from here. We're just going to hear about a lot of death. This is what we're going to hear, and it's going to get worse and worse every day for a long time now. For maybe 3 weeks, maybe 4 weeks, every day worse than the last. So just in my mind, and based on the numbers I can figure out from all the information that I've been able to acquire, if we don't do anything, maybe 250,000 Canadians are going to die in the next couple of months. If we do everything, we might keep that down to 50,000. 50,000 is still a gigantic number, but that's what we're trying to keep it down to, 50,000. That's the number of Canadian soldiers who died. That's bigger than the number of Canadian soldiers who died in the Second World War. That's what we're trying to keep it down to. So again, thank you, fellow Canadian, for being so sensible. We are, aren't we? Canadians are fact-oriented, sensible people. Thank God I'm Canadian. Now, to my American viewer. More than half my viewers are American. So there's a good chance you are American. You just listen to me. Kind of wondering what I'm talking about? No, you know exactly what I'm talking about. Now, I'm saying to you, as a friend, as a single person watching this video in America, take the steps you need to take to protect yourself. There's no help coming for you. There's no help coming for you. You need to protect yourself. You need to understand how this virus operates. And you need to do it now, right now, because you are surrounded by people who are going to get sick. Same thing here in Canada. We have one person in the hospital in my city. My city is a 30,000 person city, 30,000 people here. We have one person in the hospital with proven COVID, an older woman. She's quite sick. Nobody knows how she got it. So that tells me that there are thousands of people in my city who are sick and don't know it yet. Thousands. Maybe me. I hope not. I've been, like a lot of Canadians, I've been on guard for quite a while now for this. 2 weeks, 3 weeks? Seriously on guard for about 10 days now. I don't plan to get this disease, and I hope you don't plan to either. All that worry about going back to work, that's a pile of nonsense. No one's going back to work. Watch a video. If you're American, watch a video on what happened just watch it. It takes 5 minutes. That'll scare you straight. That'll let you know what's coming. That'll let you know why there's refrigerator trucks being parked at hospitals in the States. I'm sure the same thing's happening here in Canada. So please, I'd like you to continue watching my videos. I don't want you to die in this thing. So take it seriously. Please take it seriously, for everybody's sake. And now I'm going to stop and calm myself down because I'm all riled up here and get ready to work on this radio. And I won't mention this again in this video. So thanks for tolerating me to this point. Okay, I made the mistake of going and watching some news. Boy, that certainly doesn't help. Now, I ended the last video with a little clip of some weird stuff going on my SDR. Let me just explain that a little bit, because I did carry on. I did experiment my way through to discovering what was happening with the SDR. I got the whole thing settled down, and I'll be using it shortly on this radio. So basically, the strange things you saw in the little clip that I was so fascinated with on my SDR display was happening because I had failed to reset a setting in the SDR when I started operating it over 25 megahertz. So my SDR, here it is right here, little radio, has a frequency converter built into it, and it's able to use that converter to receive frequencies below 30 megahertz. Well, it's actually 25 megahertz. So you have a setting you put one way when you're below 25 megahertz, and when you're listening above, you must change this setting. So this radio goes up to 30 megahertz, and I just didn't think hard enough. I let my SDR, and plus the first alignment step is to do it at 30 megahertz. I put my SDR above 25 megahertz. The thing behaves crazy, makes all those funny stuff. That's why, just because I was above 25 megahertz. When I brought my test frequency down to around 20, a lot of that weird stuff disappeared on the SDR, but not all of it. So here's the other part of this story. My SDR antenna input is here. This is the cable going to it. Sometimes I hook up a stupid little coil like this. More recently, I've discovered that with some radios, this is enough. What? Actually shorting the input to my SDR still picks up enough signal in here. Just gives you an idea how much is radiating out of this radio. I had this clipped up here for a while I was doing my experiments. The oscillator coil is right in here. Yeah, it's a couple inches away. I discovered by messing around with this that in fact even at this distance it's having a small effect on these coils. What I really found was my SDR is more sensitive to overloading than I realized. The SDR has a signal level display at the top of the chart, which you've been looking at on my videos, is 0, and then it goes all the way down to minus, I don't know, minus 100 or something like that. Okay, my stupid thinking was, well, you just don't want to let it go above 0. You don't want to let it go off the scale. Turns out you don't want to even let it go halfway up. If a signal is strong enough to go halfway up on that, a little more than halfway up on that display, where are you? There you are. Chances are my SDR, the one I have, is going to go wild. So in the end, I had to hold this way out here. In fact, I ended up leaving it on the piece of paper down here. This far away, still picking up quite clearly the local oscillator, but at that point, all the other schmozzle no longer being picked up, SDR no longer overloaded, and you can clearly identify the local oscillator on it, which maybe is something I spent a lot of time on my own doing here. I don't think I posted a video of me trying to figure out which one of the crazy things was the real local oscillator. That's why this radio is here. At one point I was attempting to tune in the things I was seeing on the SDR with this radio to prove they're real, or are they just artifacts of the SDR and its display and stuff. So that's why this radio is here. I'm going to keep it here for now. Okay. And again, there's a few hours of me messing around in here that I'm not going to post. So what will happen to me as I realize now, because I'm not posting everything, I'm not sure what it is I've posted. So there's a bit of a quandary for me in my shop. I'm trying to tell the story of the repair of this radio, and I'm afraid it's getting a little busted up. But so be it. The fact is, the radio's working pretty good so far. So we're going to deal with the local oscillator and the front end tuning, and let's get some actual work going here, Jim. Okay, I'm going to set things up for that. Okay, let's start up the radio here. I think the first thing I want to do is, I don't want to build that clever little RTMA circuit that goes on the antenna here. Don't want to take the time to build that. Here I am stuck. I don't know what I've posted again. I did research into this antenna coupling circuit, if you like. That's recommended. RTMA probably stands for Radio and Television Manufacturers Association. And the circuitry that they want to use here, which is called a dummy antenna, which is a stupid name. We shouldn't call these things dummy antennas. They are interface circuits between test equipment and the radio. They're not dummy antennas. So they're always called that, but they're not. They're interface circuits. That's how I'm understanding it. This complicated one, a little network with even with a inductor in it, is designed so that what the radio feels as you tune up and down, it thinks there's nothing but a wire hooked up to it. Instead, it's actually got a piece of 50 ohm equipment hooked up to it. So that's what that circuit's doing. Now, can I get around that? The first thing I want to do is experiment a little bit with the radio and find out, well, how sensitive is it to variations in the kind of antenna that's connected to it? Because that would sort of imply, when you have a radio like this and you get it all set up and you had it hooked up to the real antenna you plan to use for the rest of your days, that's when you should do the antenna adjustment. Anything prior, like here in my shop, is kind of false. I'm trying to model the antenna that I'm going to use. I was using this RTMA circuit against a piece of equipment. Now I do have an antenna feed coming here. It's a real antenna feed, but this I don't know where this radio is going to go. I don't even know if I'm even going to keep it. It may be on its way somewhere else. So what I want to do is I want to find out, well, how sensitive is the front end of this radio to variations in the antenna. And I think that's probably a general question that should be asked about all radios. And probably the cheaper they are, and this one being a cheap one, the more likely it is that antenna connections will bugger up the front end of the radio. That's what's in my head. So in order to test this, what I'm thinking is here's an antenna, this white clip. That's an antenna. We'll tune I'll get the signal generator going. We'll tune it in on the radio, and then I'll fiddle around with this. I'll just fiddle around with this wire and the antenna connection, and we should be able to hear two things. One is the signal level going up and down, and the radio retuning at the front end, changing the front end resonance point. They're both going to sound like this. That's part of the challenge here. So to separate them, after I give an influence to the antenna and hear a change in volume, I'll then tune the radio slightly and see if it's tuned somewhere else. Now the difficulty with this is there's a number of circuits in the radio that are aligned or are about to be aligned. I haven't done the alignment yet on the front end, but I'm going to be aligned. And if I hook up a funny antenna, the first part will go out. And that'll reduce the signal coming out of the radio. I could just tune the rest of it to wherever that is, if that makes any sense. Just adjust the trimmer, I guess, on the front of the radio and get it right back to where it was. So the fact that putting an antenna on knocks it off isn't really a bad thing. It's just two things. It's interference while you're doing this kind of work, because you're all over the place with the radio and the equipment. And later you get it all tuned up here in the shop under whatever circumstances you've used, and then you put the thing onto a real antenna and you won't get what you thought you were going to get, and you probably never know. Because ultimately we all do the same thing with these radios. If they're a little weak, we could turn the volume up a bit, and without even knowing, we're overcoming weaknesses in the radio. Oh my God, I'm talking a lot today. Jeepers creepers. So we're on the highest frequency band, 20 megacycles. We'll start right here. So what am I doing? I'm tuning it for no good reason. Right around 20. This is the output from the signal generator. Just to get it going, okay, I'm just going to kind of get these guys close together. Oh my gosh, can't you even wrap a piece of wire here? What is happening to me? I think I'm stressed out. And you know, I'm pretty good at keeping calm. I'm really good at it. Not anymore. So I'm going to change the lights here so you can read some numbers. There's a big 30 up there. Let's make this 20. And we should hear it. And one of the challenges with this radio is we can probably hear this in a couple of places. So let's just snoop around here. 19.2. 1 megahertz above. 19.2. Good. I didn't want to hear it again. Well, what that tells me is probably that the local oscillator is intended to be above the received signal. We really can't be sure, you know, because 20.1 is what the radio's really tuned to. Wow. Okay, but that's not what we're dealing with right now. We're not dealing with is the oscillator above or below. We'll get to that. Right now we're dealing with is this radio messed up when you fool around with the antenna. So we'll tune it in. We'll pick the 19. Pick this one. Now, I'm going to tune this for maximum here. Okay, so there's the maximum. Just under 2.5. Now, what kind of change can I make? I can add more wire to this. So I'm going to do that. A fair bit more wire. Not a lot. Just a fair. I'll add it. I'm going to add it to the end of the clip lead here. It's tricky business because a lot more noise is coming in, but the signal level sounds the same. Let's just try it. Now, can we get more tone out of it? No? No? Okay, so my impression is hooking up this meter of wire did nothing. I'm changing the tuning situation. Let's do something a little more potent here. What can we try? What if we hook up a long antenna? I have one. Okay, so this is a serious amount of wire being added to this radio. I'm going to hear what happens here. Wasn't quite expecting that. What am I actually using to hook up? It's definitely the antenna. Okay, wasn't quite expecting that. That's always the way it goes. Okay, I'm going to clip this side onto B minus. Good. We don't get any noise. And now I want to put the antenna on here. Oh, son of a gun. Fooled it every time. Okay, so I pulled the ground off. Didn't really mean to, but I did. To the signal generator. We're still getting a signal through. Let's repeat this extra piece of wire experiment here. What the heck was that? Okay, tuning for maximum. Okay. Adding in a little bit of wire at the end here. Down. Okay. Tuning some more. If it, well, it's hard for you to watch this. Like, I know what my hand's doing, so I can watch this. Tuning. Down. Tuning. Ooh, did it go up there ever so slightly? Wow. Okay, so tuning to the max. Yeah, every little movement I make might do this. Now, does it drop when I take this off? Hang on. Oh boy, that was a tough one to see, wasn't it? So it's right on 4 decibels right now. And with it on, it's slightly lower. Oh my gosh, it's a hair trigger. We need to do something more dramatic with this antenna connection. Sticking a bit of wire on it. There's a lot of wire. Stay away from this antenna thing here that I've got. My experiment is going down the drain again. Yeah, we don't need that so loud for crying out loud. What else can we try here? Stupid things. I take a little tiny capacitor and put it right across the antenna terminals here. Well, that sure affects it. Knocked it right out. I don't think I can do my experiment. What I'm discovering is it's not easy to knock this thing off. It could be, well, I'm on a fairly high frequency. I was going to say it could be because I'm working at too low a frequency, but I'm at 20 megahertz here. I think what I'm going to do is I'm going to proceed with the alignment exactly how I have this connected right now. How similar this is to a real world antenna, I don't know. Well, we're going to just follow this. Do it like this. Okay, don't sound so depressed and disappointed, Jim. It's not that big a deal. Now we'll go and follow the instructions, which are to do the oscillator alignment at 30 megahertz. So let's take the whole show up to 30. That's about as close as I'm going to get there. I'll tune this guy up to 30. What's happening there? Is that this? No, you know that sound, that's coming out of the radio on its own. What is happening there? A wild guess could be the alignment of the radio is actually better up in this area, and it's actually able to receive this sound thing, this noise thing. It can't receive it down here. It's actually a sign that it's better up here. I kind of doubt that, but let's just carry on with the alignment, and we'll just do the alignment and see, maybe some of these things will go away. That's the best way to look at it. Maybe your problems will just go away. So, now we never got this tuned in. Okay. This is now tuned to 30. I'll have to find it on this guy. What is happening with this thing? $28.79. Oh boy, that just sounds terrible. Very low signal, that's what it is. So we're getting 28.7 and it's tuned to 30. 28.7. See if we can get it to 30. I don't think we can. Secretly, without telling you, I've actually done this already on this. I was partially working through this oscillator when all these weird things started happening with the SDR. So this is exactly the point I was at when I went off into SDR Never Never Land, trying to prove the local oscillator frequency on my radio, which we may end up doing very shortly too. It may be sooner than shortly. In fact, this capacitor is open quite a ways. It was closed tight. These are all closed a fair bit. I opened this one a long ways to try to raise that frequency up, and started thinking, no, you know, there's something going on with which side of the target signal the local oscillator is on. That's what got me onto the SDR and into SDR Never Never Land for an hour and a half. I think we need to look at the SDR. We need to know for sure where the local oscillator is before going any further. So I'm going to get ready for that. Okay, now you can already see that there's one strong signal kind of on the right side of the panel there. You can see the blue line coming down. You can see where the radio is. Here's where the lead is being held. I'm holding it way back here, and it's picking up the local oscillator from that radio. Now watch as I just come closer and closer to the radio here. Now remember, there's a delay on the SDR. You can see that it's become higher. The color has changed on the waterfall. You get right up there. Now something to really look for on the waterfall display. It's easy to see variations in frequency on the waterfall display. It's right now it's a straight line because there's no variation. I'm holding still. But if I move a little bit, no, the signal went away. It went away a little farther than I'd hoped, so we can't really see it on the waterfall. It did not change frequency. But let me bring this up now. If we get close, will it change frequency? It already has, but I'll just demonstrate by getting really close. And you see on the SDR, especially if I wiggle this, if I do this kind of thing, and you can see that clearly it's affecting the so this is another factor. I had put this here and fixed it in place, and I didn't realize that I'd thrown the coil off here. So I don't want that to happen. So that's why I'm doing these experiments, just checking sensitivity. And so this far away doesn't seem to affect the frequency much at all. Yet I'm able to pick it up gloriously. So I'm just going to put this here. I'm going to fix it in place. We can't be moving the radio, can't be rotating it now or anything, or it's going to change the signal level. Okay, so that is a local oscillator for sure. That thing, I will tune the radio slightly and see. Oh, it changed frequency already. Really, my hand coming up to it changed frequency. Is that because I'm coming up towards the base here? Yeah. But I put my hand way up here. Is it touching the cabinet? What happened there? Wow. Is that just me touching the cabinet? Oh, what happened there? Can't have these things happening when you're doing an alignment. Oh. What's shaking? Is it the antenna? The antenna? Oh my gosh, look at that. It's the local oscillator that's being thrown off tremendously by fooling around with the antenna connection. Really? Is that so? Let me just disconnect this completely. Oh my gosh, look at that. The local oscillator is what's sensitive. But how can that be? The local oscillator is not hooked up to the antenna. How could this happen? Some kind of capacitance within the mixer tube that's making the local oscillator and the antenna do something together. How do you get changing the antenna conditions causes the local oscillator to change? Is it just because I move stuff around on my bench? Is that what it is? So I'm going to put this this line more central in the screen here. Just moving the whole display over, so here it is over here now. Okay, so there's just a clip lead hanging here, going nowhere. What if I just, let me just put my hand on it without moving it. Holy smokes, look at that. There's a lesson. I would never have thought this would happen. Well, this is a major disturbance in the radio. This is a huge disturbance in the radio. It's one thing if you're tuning the front end, and it's just not as critical as the local oscillator. What would happen here is it would go through the whole process of setting up the local oscillator correctly. When you disconnect the equipment or change the antenna connection, the local oscillator goes somewhere else. The problem is not just that that's going to cause the dial to be inaccurate. This is no precision in this dial anyway. The problem is you get all these things lined up, and then when you disconnect your equipment, one's not lined up anymore. Hook it all back up. Hey, it all seems fine. What's the problem? No problem. Disconnect it. It's off again. That's what I'm facing here. Sounds like I better build that RTMA circuit and just do what the book says. So what if you have isolation? What if we stick, I happen to have a resistor handy here. This is not a big one. This is a 390 ohm resistor. What happens if we, 390 ohm resistor is typical resistance for an antenna, a wire antenna. So, okay, so there's the oscillator. Why has it gone down so weak? Why did it get weak? Because the oscillator signal is coming out of the antenna. The oscillator signal is present on the antenna. That's also part of the picture why the antenna is so sensitive to it. So, is that true? So, so that would mean if I lengthen the antenna, more oscillator will make it to my little pickup coil here. So I see the frequency jumped. It's off the screen. I have more waterfall to watch on my computer screen. That's the full version of it. You're just seeing the top part of the waterfall. I had a chance to see a frequency shift there for reasons I don't know. Okay, we're gonna just clip this on and see what happens. I have to clip it on. I got my hands all over it. Everything's causing an influence. Here we go. So it's strong again. My guess is that's because I now have a better radiative antenna here. And it shifted frequency, which is off the screen that you're looking at, but I can still see it. Oh my gosh, this is quite a problem. Is this true on every band? Probably. I think we need to look at the circuit diagram and see if we can't identify why is the local oscillator so sensitive. Or has something gone wrong in this radio? Which I don't think so. I think this is probably why they recommend that RTMA patch, because the designers of this radio knew if you tried anything else, They're going to mess up the local oscillator and get a bad job done. That's where I might end up going. It's not the end of the world to build that little circuit. Local oscillator, so sensitive. I'm going to bet you that's why there's no metal plate here. That's why this radio came with a cardboard plate. Because they knew if you did all that alignment work and then stuck a big piece of metal up here, goodbye to all of it. So maybe this is a hint too. Believe it or not, finding this would mean finding a cardboard bottom means the radio is sensitive to this kind of stuff, and they couldn't have a metal plate there. Now, some radios are designed so you can put the metal plates on, have everything on, and then do the final alignment. But this guy, you can't do anything really with this. You got to take it off. So another way to get around this is in some radios they have holes drilled through the metal plate, and you can do the alignment with the plate in place. I've never, well, yeah, in that case I would think it would throw the local oscillator off. That wouldn't surprise me. But antenna connections? Yeah, let's go look at the schematic here and find out what is going on here. So this is all antenna stuff here, and this is all oscillator stuff. Now, how does this oscillator stuff well, you know, just as a wild guess, there's a gain capacitor in here. That's a point where these two circuits are kind of physically close together with radiative plates involved. That means putting my hand near that capacitor would really have an effect, if that's what it is. If these things are linked just by the fact that they don't exactly share a capacitor, but it's very close. Now the signal coming out of here goes onto this first grid. This is typical in a radio like this. So that's going into the tube. This is going into the tube as the cathode. So this line from the antenna is coming into grid number 3. There are capacitances between all these grids. You try to reduce it by screening here. But it could be fiddle with the antenna, fiddling with this, is fiddling with this grid, is working through the tube to end up fiddling with this wire, which is then fiddling with the resonance of this. Oh, that's far-fetched. That's too long a story. That's got too many chapters in it. Got to be something much more simple about why fiddling with the antenna. I don't know. You know, another possibility is there's coil interaction here. They're not supposed to be, and we try to make these coils so they don't interact. I notice in the radio they're not quite on right angles. They're close to being at right angles, but not quite. There could be some interactivity. How would that cause it? I can't believe it. This is a significant variation in the local oscillator. This is not small bananas. Those little wiggles are actually a lot in the radio. That would even mean if you had the radio all set up and operating and aligned with its permanent antenna and everything, if you stuck your hand too close to something, you'd be off again. You know, I think it comes into the category of this is a lousy radio. Unless there's something wrong. Unless there's something wrong, that can be corrected. And I'll bet you there isn't, or they wouldn't spend time telling you about this. Okay, so I gotta build this. I'm gonna build this. I gotta build this now. 20 microhenries. That's the problem. I may have something like that. So I'm gonna go away, build this little circuit, and then you know, we could look for sensitivities on the far side of the circuit. I'm not sure how, but I don't know. Okay, that's what I'm doing, building the circuit. Okay, well, I think I made a really important discovery here about this radio, and I got my hands on my head here. What about all the other radios that I've worked on? How many of them have a local oscillator that can be knocked off by something simple like a variation in the antenna? Never seen it before, never thought about it before. So this really is quite a big deal to have discovered this. And thank you, SDR. As much as I have all kinds of problems using the SDR, occasionally it really comes through, and I think it's really come through this time, for sure. So I'm going to stop the video at this point. Too much going on in life, of course, for me to stay in here anymore. But I will build the little circuit. Tomorrow we will test the circuit to see if it somehow compensates for variations in the antenna, and if it doesn't, if in fact it makes it possible to align this radio properly. So that's what we'll do tomorrow. In the meantime, everybody stay safe, stay away from people, don't touch anything, don't touch your face. If you've gone outside and you've been around people, don't touch your face. See ya.